Alright, today I'm going to go over the final review in case you have any last minute questions before the final, which yours will be on Thursday for 5th hour. So the first one you really want to focus on is your vocab, which has to do with these angles up here. So you first should know that angle A and angle D are vertical angles. And you should know that then they are equal to each other. Angles D and E, and we're going to do this D and E, are a linear pair, which means they add to 180 degrees. Another word for that is supplementary. Angles A and C are also a linear pair. They lie on a line. So they add to 180. And then we get to angles C and F. Let me clean this up a little bit. C and F are corresponding. They're the exact same spot, just shifted down a level. So that's called corresponding. And then angles B and F are alternate exterior angles. Oops, if you can read that, alternate exterior. And these ones are also equal or congruent to each other. Right, so then we get to we're using those vocab words. So what you're going to do down here first is I'm going to spread 85 everywhere. So I have vertical, alternate interior, and then vertical again. So you should notice that 2x minus 23 and 85 are equal to each other. So the equation you set up is this, and I'm going to assume you can solve that by adding 23 and then dividing by 2 so you can finish that. I'm just going to set them up for you. Notice that 105 and 4y minus 15 are alternate interior angles. Those are equal to each other. They're congruent angles. So you get 4y minus 15 equals 105. And I'm going to assume you can solve that by adding 15 to both sides and then dividing by 4. So you get 120 divided by 4. Get a little more room here. So y should equal 30, I take it. Alright, then we get to the last one. It has two variables, so you're going to need to set up two equations. So first, 108 and 5c plus 8 are vertical angles, which means they're equal to one another. So you're going to set up equation 5c plus 8 equals 108. It's your first equation. Your second equation is going to be to set up 108 and 6a minus 18. These are corresponding angles, which means they're also equal to one another. Second equation is going to be 6a minus 18 equals 108. So notice that all of these were set equal. The only time you add to 180 is if you have a linear pair. Otherwise, all the other types are congruent to each other. All right, 9 and 10 have to do with the midpoint formula. Remember the midpoint formula is x1 plus x2 divide 2, comma, y1 plus y2 divide 2. So the first one just asks you to find the coordinates of the midpoint. So number 9 should be pretty straightforward. You add your x's, so you get 1 plus 5 divide 2. And you add your y's, 8 plus negative 2 divide 2. And you make my negative bigger. So when I do that, I get 6 divide 2, which is 3. 8 minus 2 is 6, so you get the point 3, 3. Number 10 is a little trickier, and I'm going to draw you a little visual. So I have a point. I have a segment here that's CD, and I have a midpoint too. I'm going to label that M. So C's coordinates are negative 3, 10. The midpoint is 5, 6, so I need to find out what D is. So to do that, I'm going to say from negative 3 to 5, I add 8. And from 10 to 6, I subtract 4. So then from the midpoint, I'm going to add 8. So 5 plus 6 is 13. And then I'm going to also subtract 4. So 6 minus 4 is 2. So I get the end coordinate of 13, comma 2. Another way to do this is the same thing. I'm just going to draw it more visual for those. Sometimes I do this. I write negative 3, 10. 5, 6, and then write my last coordinate below. Same idea. To get from here to here, I add 8. To get from here to here, I subtract 4, so I follow that same pattern. Add 8, I get 13, and subtract 4, I get 2. Either way, you get the same coordinate, and you're doing the same method. All right, 11, 12, and 13 all deal with slopes, so you need to remember the slope form is y2 minus y1, x2 minus x1. So the first one's pretty straightforward. Negative 8 minus 7 over 9 minus 3. You get negative 15 over 6, which simplifies to negative 5 over 2. So that's number 11. Number 12, you need to know that the slope of a perpendicular line is the opposite reciprocal. So if the original slope is negative 5/2, the new slope has to be the opposite sign, so it's going to be positive, and then you have to flip it, so you get positive 2/5. And 13 is dealing with two different points. It's a little bit different, but it's still the same idea. We want to know parallel, and parallel have the same slope. So first you need to find the slope, negative 10 minus a negative 4, which turns into a positive, over 2 minus a negative 1, which again turns into a positive. So I get negative 6 over 3. So the slope of that line is negative 2, and the slope of a parallel line will also be negative 2, so your answer is just negative 2. Move on to 14. It asks you to sketch this, so all you're going to do first is plot the points. Negative 1, 1, 4, negative 1, 3, 4, negative 1, 6. And I'm going to connect it. Just get that one fixed a little bit. Right, and then it asks us to sketch it. We did that. Then it says, what's the slope of each diagonal? So I need to draw my diagonals in. So first I'm going to draw this one in. And to find the slope, I'm just going to count up 3 over 4. So the slope of one diagonal is 3/4. I'm going to draw the next one in. This one you go up 1, 2, 3, 4, 5, 6, 7. And over 1, 2, 3, 4, 5. You went to the left, so it's negative 5. So slope of this one is 7 over negative 5. And are the diagonals perpendicular? The answer is no, because they are not opposite reciprocal. So they're just looking to see if this shape could be a rhombus, a kite, or a square. And since they aren't perpendicular, it can't be a rhombus, a kite, or a square. And you're going to see that it actually isn't even a parallelogram because the sides aren't parallel. Right, so this one, the next page is all about making sure you can sketch pictures based on what they have. So they have C is the midpoint of AB. So you should draw a segment with endpoints AB and plot C in. C is the midpoint, so it's going to be in the middle. AB is 12, so the whole thing is 12. AC, they want to know what AC is. AC has to be 6. Right, this one is a little tricky, just you have to read it. So TR bisects angle STA. So as soon as I see angle STA, I'm going to draw angle STA. So there's STA. And TR bisects it, so I need to draw an angle bisector in, so that's TR. It says the measure of angle STR is 34. STR is right here. This angle right here is 34. Give the measures of the other two. Well, angle ATR, which is right here, is also got to be 34 because it's cut in half. And then the last angle, the full angle, angle STA, has to be 68 then because it's the total of both of the angles. Number 17 is very similar. You have a line PQ, so you're going to draw a line PQ. You have a line DF that intersects PQ at point A, and keep reading before you start drawing. The lines are perpendicular, so I'm going to draw a line in. It's DF intersecting at point A, and the last thing I know is that they are a right angle. So it says the measure of angle PAD is 3x minus 27, so this angle is 3x minus 27. But what I also know about that angle is it's got to be equal to 90. So I'm going to make my equation be 3x minus 27, and I also know the angle is 90. So then when I go to solve, I get 3x equals 107. Whoops, 117. Divide by 3, and you get x equals something. And I don't have the answer on hand, so we can solve that later. Alright, 18 through 20 are also very similar. You just need to read it and draw pictures. So it says angle SUP and PUL are a linear pair. Remember, a linear pair means they lie on a line. So I have SUP and PUL. SUP is 2x plus 7, and PUL is 6x minus 11. Again, linear pairs add to 180, so your equation is going to be 2x plus 7 plus 6x minus 11 equals 180. So you get 8x minus 4 equals 180. 8x equals 184. So x equals, let me grab my calculator. So 184 divided by 8 is 23. Oops. So x is 23, and it also says find the measure of each angle. So what you have to do this is plug it back in. So you're going to do 2 times 23 plus 7 to get that angle, and you're going to do 6 times 23 minus 11 to get that angle. So angle SUP is going to equal 53. Oopsie. And 6 times 23 minus 11 leaves me with 127 for angle PUL. And you can always check, these two should add to 180, so 53 plus 127 should give you 180, which means I solved the problem correctly. Right, so this one says P is the midpoint of EN, so I'm going to draw a segment EN, and P is the midpoint. N is the midpoint of ER. Notice I already have N right here, so I just need to extend this. So if N is the midpoint of a segment, I need to double it, so I get ER, and N is the midpoint. So it says, what is the length of ER if EP is 7? So I know this little guy's 7. And since it's the midpoint of PN, this also has to be 7. And since N is the midpoint of this whole segment, that totals 14. This whole segment right here has to be 14. So the total of the entire segment has to be 28. Right, number 20 starts to get confusing, but you just have to draw an angle. So I first have to draw angle MAT. And AH bisects that angle, so it's an angle bisector, so this is AH. It says the measure of MAH, right here, MAH is 5x plus 8. And the measure of HAT, right here, is 2x plus 47. The one thing they want you to look then is these two angles were bisected, so they're the same. So the equation you should set up is 5x plus 8 equals 2x plus 47. Solving that, you get 3x equals 55. Oops, not 55. I have to subtract 8 over. Equals 39. So x equals 13. And then it also asks you to find the measure of angle MAT. To do that, you go back and grab the 5x plus 8. And you plug in 13 for x. So I get 5 times 13 plus 8. So the measure of this angle is 73 degrees, which means if I were to plug in 13 here, I should also get 73 degrees because they're supposed to be equal. And I did get 73 degrees for this one as well, so they both equal out. Right, these ones are just word or definitions, but I do want to make sure I go over these just so you have a good handle on these. So angles that measure up to 180, you could put linear pair, but the word that we're really looking for is supplementary, so that's F. And what that really means is you have two angles, so let's say this one's 30. The other one has to be 150 if they're going to be supplementary. So you have to add to 180. 90 on the other hand, let's say I have one angle that's 40 degrees. The other one has to be 50 because they are complementary. So the word that adds to 90 is complementary. Two lines in the same plane that do not intersect are lines that look like this. They're going to be parallel because they'll never intersect. Two lines in that intersect at a right angle should be perpendicular. So you're looking for something like that. That's G. A segment in a triangle connecting the vertex to the midpoint of the opposite side. So if I have a triangle, I'm connecting vertex to midpoint of opposite sides. So you should just see these markings. Now sometimes it could be perpendicular, but it doesn't tell us that. So the only thing we know is that it's called the median. Segment that's perpendicular to the opposite side could be something like this. Again, we don't know that it cuts it in half, we just know that it's perpendicular, so the answer to that is altitude. So perpendicular is altitude, middle is median. When we combine the two, then we get the perpendicular bisector. And then the last one says a segment in a triangle from vertex dividing an angle into two parts. When you see the word angle in two parts, you should think bisecting, so it's a angle bisector. I'll get my pen to work here. Whoops, too far. All right, moving on. Whoops. Did I do the other ones? Where'd my circle go? All right, so this one I wanted to go over really quickly, just the circles. I don't have the one graphed there, so I'll just make one up. But what I want you to remember is the circle, you'd use the opposite sign for these. So the center would be -2, +4. And remember the radius, you square root, because in the equation it's squared, so it would be 7. So hypothetically, if you had a circle here, I think the center on yours is -6, and I believe if you count, you'll get a radius of 5. So hypothetically here, we have a circle. I know it's not showing up, and that's not a great circle at all, but if I wanted to write the equation, it'd be x plus 6 squared, because it's the opposite sign. Y minus 2 squared equals 5 squared, because in the equation, remember, the radius is squared. So your final answer would be x plus 6 squared, y minus 2 squared equals 25. So just don't forget that circles should be pretty easy if you study them. It's just the opposite sign. Right, and a lot of people got tripped up on this one, but it's really just asking you to compare where the letters are. So you see IF right there. That has to be congruent to HA. Angle TWH, so TWH has to be congruent to ELI. You're just following the same order. EL, so EL has to be congruent to TW. Same spot. And then angle E is in the same spot as T, so angle E has to be congruent to angle T. So that's pretty straightforward once you get the hang of it. It's just comparing where the letters are. All right, we already talked about this a little bit. So median, you should be looking for a midpoint. So if you read up here, it says angle BAE. That angle. Oops, too far. Angle BAE is congruent to angle EAC, so this angle right here. So this segment right here must be our angle bisector, if that's where it's at. So AE is our angle bisector, so that's letter B. It also says that BF is congruent to FC, so BF, FC, that must mean that this part's congruent to this part. And F is our midpoint then. And that's important for finding the median and the perpendicular bisector. So GF, you can see right here, is the perpendicular bisector. It's perpendicular and it's crossing through the midpoint. So GF, which is letter D. Also through the median should be the median. Or also through the midpoint, excuse me, should be the median. So AF is our median here because it's connecting to the midpoint. So that's letter C. The last thing is the altitude, and you should remember just be looking for a perpendicular from vertex straight down. So AD is our altitude, which is letter A. All right, determine if it's true or false. If in a triangle has two angles of equal measure, the third angle has to be obtuse. That's false. And it says provide a counterexample, so I'll draw a triangle here. I could have a triangle that's 70 degrees and 70 degrees, which still has two angles congruent, but that would make this top one be 40, which is not obtuse. So that's my counterexample for this one. All right, the four angle congruence theorems that are AAA, ASA, side, 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 and side, angle, side. That is false because angle, angle, angle is not one. So the last, what I would want to write to change this would be angle, angle, side, or side, angle, angle. That's the one that would make it true. The two that don't work are angle, 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 and side, side, angle. Okay? The sum of the angles in an acute triangle is the sum of the angles in an obtuse triangle. And I should hope that you're all thinking, well, that's silly. It's false because all triangles, regardless of their angles, have to add to 180 degrees. Okay? And this last one going along here, CPCTC, corresponding parts of congruent triangles are congruent. So make sure you know what CPCTC stands for. I know you know how to use it, but you need to know what it means as well. All right. Again, whenever you see a problem that doesn't have a picture, you're going to want to draw a picture. So I have an isosceles triangle, and I'm going to make it this way. The base angles measure 37. Remember, the base angles are where the non-congruent sides are. So the base, basically. And then it says, what's the measure of the vertex angle? So I'm trying to find this. Remember, triangle has to add to 180, so do 180 minus 37 minus 37, which leaves me with a vertex angle of, oopsie, 80 minus 37 minus 37, leaves me with a base angle of 106 degrees. So this angle up here is 106 degrees. So that one's pretty straightforward if you draw a picture. Right, which of the following sets could be triangles? Remember the two smaller ones has to add to be bigger than the largest. So it looks like 4 and 6. 4 plus 6 has to be greater than 10. Is 10 greater than 10? That one would be no. You can't have them be equal because then it forms a straight line. Right, so this time I'm going to take 48 and 4. Don't just add the first two. You got to look for the smallest one. So 48 plus 4 has to be bigger than 50. 48 plus 4 is 52. So that one would be yes. And then the last one, don't just pick the, well, this one I can pick the first two because they're the smallest. So I get 25. Is that greater than 50? And that one's clearly no. Again, I see one that's got all these words, and I don't have a picture, so I'm going to draw a triangle. TRG. Measure of angle T is 29 degrees. Measure of angle R is 5x minus 5. Measure of angle G, oops, I had to put a C, it should be G, is 7x. And now with my picture, I can quickly see, well, I've got all three angles in a triangle. They have to add to 180. So 29 plus 5x minus 5 minus plus 7x has to add to 180. So I get 12x minus 12x plus, excuse me, because 29 minus 5 is 24. Has to equal 180. 12x equals 180 minus 24. Gives you complications here, 156. divide by 12. So I get x equals 13. Now notice that the question didn't ask me to find x. Oops, I had it switch colors in the middle, excuse me. Didn't ask me to find x, it asked me to find the measure of angle R and the measure of angle G. So I go back up here and plug in 13 for x. So 5 times 13 minus 5. Oopsie. So I get x, measure of angle R, to be 60. And this one I'm going to do 7 times 13. And I get 91. So what I should check is 91, 60, and 29 should all add to 180. So I would just do a brief check, 60 plus 91 plus 29. And they all total 180, so I definitely got my answer correct. Too far. Alright, next ones are proofs, and some of these I'm going to skip over because they're a little bit hard to draw on. But this one should be pretty straightforward. You should see that these are vertical angles. So you could write triangle ABC. You notice that A is right here. It's congruent to E, so if they started with A, you have to start with E. So if you went from A to B, on this side you're going to go from E to D, EDC, and your congruence conjecture is angle, side, angle. The side is between the two angles, so you should be good. This one, you know that EC is perpendicular to CD. So you know that this is a right angle, and this is a right angle. And you also know angle A is congruent to angle D. And that's all the information you can gather. So this one you would write not enough. You can't even write a congruence conjecture. All right. This one says CD bisects angle C. So CD bisects this angle, so this is congruent to this one. It also says ABC is isosceles, so this side is congruent to this side. The last piece you have is that CD shares a side. So angle AC, or triangle ACD, is congruent to triangle BCD. And the conjecture is side, angle, side. It's the angle between the sides, so I get side, angle, side. All right, now this one's a little tricky, and there are multiple ways to do this one. So it says ABC is isosceles with vertex angle C. BD and AE are medians. So what that means is that this side's congruent to this side's congruent to this side, and they're actually all congruent to each other since the triangle is isosceles. The other thing you know is that this whole angle is congruent to this whole angle because it's isosceles. And then the last thing is, let's see, we're looking at ABD, so what I want to do real quick is highlight the triangles I'm looking at. I'm looking at triangle ABD. This one right here, colored in. And I'm also looking at triangle, I think, AEB. So I'm going to draw those separate. This one gets a little tricky, especially since my drawing skills aren't good with this writing tablet. So I got ADB. I know this angle is congruent, and I know this side's congruent thus far. And I got AEB. I know this angle is congruent, and I know this side is congruent. The last thing you should see now that I have drawn these out separately is that AB and AB are congruent to each other. So ABD is congruent to BAE. So let me just check that ABD, BAE. Yep, that's correct, and it's by side angle. Side. It's not the only way you can arrive at that one, but it's good. Alright, these ones are properties. I would study your properties, and there's multiple answers, but we're going to put the post basic one. Equal angular means all the same angle, so it has to be a rectangle or a square. A square is more specific, so we're going to go with a rectangle. Quadrilateral with exactly one pair of parallel sides. The only one that works for is a trapezoid. And equilateral quadrilateral. Again, that has to be all equal sides. The answer to that is a rhombus. A figure with all congruent sides is equilateral. That's the word. That's the one we just talked about. It's a rhombus that is that, but the word we're looking for is equilateral. A figure with all congruent angles, they don't have this as an option, but it's equiangular. A line connecting a line segment connecting two non-consecutive vertices is a diagonal. Quadrilateral with two pairs of consecutive congruent sides. The only one that has consecutive or next to sides that are congruent is a kite. So remember, we got two sides that are congruent, and then another two sides that are congruent. I know that's a terrible kite, but it'll do. Quadrilateral with two pairs of parallel sides. That's the definition of a parallelogram right there. And an equilateral and equilateral quadrilateral, that's a square. It's both. Right? I would study the properties on those shapes. Alright, sum of the angles. I just want to see what we have left. I'm actually going to do another video because this one's getting really long, so if you want to watch the rest of it, you can check the next video.